Okay, today we're going to talk about Chapter 3, Scientific Method. If you can understand a few things about scientific method and data representation, then you will be able to quickly look at graphs and understand them better without having to waste time reading the passages. So it's worth sort of going over and jogging your memory about what some of these things are and what they're talking about. So if you will open your book and follow along with me, you can highlight too if you want to chapter 3, which begins on page 52. So let's talk about the elements of an experiment. So this should be review, but just so you know, this little box right here gives you some good information about the elements of an experiment. If you want to talk about independent variables, dependent variables, constants in the control group. And really, as we talk about these things and as you understand them more, you can actually then glance at some of this data representation in these questions and not really even have to look at the passage to be able to understand some of the things that are going on. Okay. So let's talk and review just about independent variable, one of the elements in the scientific method. Okay, so we got independent variable here. The independent variable is the thing that you are changing that impacts the outcome of the experiment. Okay, so it is usually on a table. It's usually in the leftmost column. And then on a figure, what I call a graph, but they call in the ACT a figure, it is usually either on the x-axis, the legend, or the y-axis. It is most often on the x-axis, but we're going to look at it in all three places, okay? And so sort of this gives you how to remember it. What you change is the independent variable, okay? Then let's talk about the dependent variable. The dependent variable is the thing that you are measuring, the thing that is impacted by the change of the independent variable. On a table, it is generally in the rightmost column. On the figure or a graph, it's usually on the y-axis, but it can be on the x-axis. We'll look at that. So to remember it, think about it as being the thing that you measure, okay? Constant is the thing that does in the experiment that does not change. On a table and on a figure, it generally is not there. Okay, so you can actually assume that everything else is actually constant if they don't mention it. Okay, so if temperature isn't mentioned, then you can assume it's constant. If time isn't mentioned, then you can assume that it is a constant, or I guess like the window of experiment. Okay, the control group is your basis of comparison. It's generally not on your table or your figure. Okay, so let's look. This graph right here is really what you will most typically see on the ACT. Forgive my terrible arrow. It's hard to draw like this. But this is what you'll most typically see on your figures. You'll have the independent variable here. You'll have the dependent variable here. So the thing that you're manipulating purposefully to impact the dependent variable is generally you'll see it on the x-axis. Now, here you have a wrinkle in this second graph. If you see, time is down here. Time is generally an independent variable that you're altering, but when you have time, you can also have an additional independent variable. So in this case, your independent variable is up here in the legend, okay? And then your dependent variable is still over here. This third one is when they have flipped the independent variable and the dependent variable. This time you have the dependent variable down here, and then you have altitude or depth up here. This is actually your independent variable. It's what you're manipulating. If it does end up like this on the ACT, it may be helpful just to flip the graph, rotate it, so that you then have the independent variable kind of what it looks like on the x-axis. Okay, so just to review, independent variable is that thing that you are changing, that you can control it and you can change it, okay? And it's what impacts the dependent variable. The dependent variable is what you're measuring. is the thing that is impacted by the independent variable. Your constant is the things that do not change, and it's the things that are really not mentioned or not there on your table or your graph, and then your control group is your basis of comparison. All right, let's look at our next page. For some reason, it is not really letting me move to the next page. So I'm going to have to stop recording for just a minute and then. Okay, now looking at the scientific method tables. So in the scientific method, hang on just a second. Okay, so let's look at these examples here. You have scientific method tables, and remember how we said the independent variable is generally to the left on a table, and what the dependent variable is generally to the right. Another way to think about that is like when you're actually controlling the variable, you're generally going to control it in nice round numbers. And if you look, especially in samples 1 through 3, sun is our independent variable, and you notice, and then height is what we are changing or what we're measuring. So that's our dependent variable. So this is what we're changing to impact height. So, and if you notice, one clue is that when you are controlling a variable, you're going to control it in little round numbers. And then what you're measuring though is in decimals, because you can't control the outcome. That's the dependent variable. So you see sun here is our independent variable, changing at 20%, 40%, 60%, and then this is our dependent variable. Now, what would the soil be and the water be? They would be the constants, right? Okay. Now, look in 4 through 6. Now we see that sun here is what? A constant. And now we see that what we are changing is the soil. A, B, or C. That's our independent variable. It's to the left. And then water is also still a constant, and then height is still our dependent variable, what we're changing. All right, then look at 7, 8, and 9. Sun is what? Constant. Soil is what? Constant. So now our independent variable that we are changing is the amount of water, and then the height is still the dependent variable to the right. Okay, so a couple things. In an experiment, you can only change, in science, you can only change one variable at a time to impact outcome. So if you notice in this one experiment, in the first 3 samples, they're changing the sun, then they're changing the soil, then they're changing the water. You can only do one at a time. So when you change when you make a different variable your independent variable, then the others have to become constant. Okay, so here's what I want you to do. Look at this table and then try to answer the questions below. So let's work number 1 together. It says, based on samples 7 through 9, so it's these right here, which element represents the independent variable? So everybody look. Is it sun? Nope, because it's all the same, so that's a constant. Is it soil? Nope, because they're all the same. So is it water? Yes, water is what is being changed by the experimenter in round increments. And then, so that would make this our independent variable because it's what we are changing. And then height would be our dependent variable, is what we are measuring, okay? And that follows the pattern. The independent variable is to the left and the dependent variable is to the right. Let's look at number 2. Based on sample 7 through 9, which element represents the dependent variable? We just said height, which is correct. Then it says based on sample 7 through 9, which element represents constants, okay? So we already talked about that. We said that the sun and the soil were both constants. So C should be your answer, all right? All right, so let's move on to 3.3. And we're looking at scientific method figures. Oops, sorry. Look at 3.3. Okay, so looking at this figure, I think there's some important things to kind of note here. For the purpose of the ACT, when you see time on your x-axis, it technically is an independent variable that is being changed in increments, but for the purpose of the ACT, you just want to ignore it. And so if you see time on the x-axis, then you see a legend up here, then you should assume that these are your independent variables. What we are changing specifically to impact concentration. So in this figure, the independent variable is here in the legend, okay? A dependent variable will actually never be in the legend. It will either be on the X or the Y axis. Most often, the dependent variable is going to be on the Y axis, but not always. But as we have seen, the independent variable can be on the X axis, the Y axis, or in the legend. If it is in the legend and time is down here, ignore time as your independent variable and focus this as being your independent variable. So here's the thing. Do you see anything else that is being changed? What about air pressure? What about temperature? Do you see any of that on here in this experiment? You actually don't. And sometimes they will try to throw you in a question asking you to look for air pressure or temperature. If they ask you that and you don't see it on if you don't see those things that they're asking about, those locators they're asking you about, then you should assume that they are constant. So I'm going to annotate this, I think. So look here. So it says right here, do you notice any other variables besides pH, exposure time, or concentration? Okay. If you are looking for additional variables because of the locator, then you, and you can't find those variables, then you can assume that they are constants, okay? And you can do that without reading any text, okay? All right, so does everybody see that right there? I would highlight all this, okay? So if you see in this figure, we've got independent variable, pH is being changed. What is being measured is the change in concentration levels. Exposure to time, you can just ignore as an independent variable. So let's look at the sample questions below. Based on the figure, which element represents an independent variable? Okay, so let's look. We've got water temperature, we've got survival percentage, and we've got treatment 1, 2, and 3, okay? So what is going to be our independent variable? What are we changing specifically to impact outcome of survival? It should be water temperature. If you look, I know that there's a legend here, but look how they don't give you the legends. They don't give you what's treatment 1, 2, or 3 as a possibility. So F, temperature, is going to be your independent variable. So based on the figure, which element represents your dependent variable? Well, this should be obvious. If you're changing the water temperature, what are you measuring? You're measuring the percentage of survival. So that's going to be your dependent variable. Remember, dependent variable is what you're measuring. B is your right answer here. Sorry. All right, so based on the figures, which element represents a constant? Okay, so we know it's not water temperature. We know it's not survival percentage because we know that's your independent and your dependent. So it could be treatment type or it could be air pressure. But since we see treatment type on there and it is obviously changing, it's not a constant. So we can only assume that the right answer is J, air pressure. Everybody understand why? Hope so. All right. Think about questions, write them down if you have any, because I'll answer on our Zoom call this week.